Hello, students. Good day. Welcome again to our Math 9 class. So, this morning, we will be talking about another topic that is one of the topics of variation, direct variation. Do you know that an increasing demand for paper contributes to the destruction of trees from which papers are made? If waste papers were recycled regularly, it would help prevent the cutting down of trees, global warming, and other adverse effects that would destroy the environment. Paper recycling does not only save the earth, but also contributes to the economy of the country and to the increase in income of some individuals. This is one situation where questions such as, will a decrease in production of paper contribute to the decrease in the number of trees being cut, can be answered using the concepts of variations. There are several relationships of quantities that you will encounter in this situation. You will learn how a change in one quantity could correspond to a predictable change in the other. In this situation, what variation is illustrated? The area of a field to the number of trees to be planted. This is a direct variation. Why? Because if you will plant many trees, you need to have a big area of a field. Now, what is a direct variation? There is a direct variation whenever a situation produces pairs of numbers in which their ratio is constant. The statements y varies directly as x, y is directly proportional to x, and y is proportional to x may be translated mathematically as y equals kx, where k is the constant of variation. For two quantities x and y, an increase in x causes an increase in y as well. Similarly, a decrease in x causes a decrease in y. So that's direct variation. If one quantity will increase, the other will increase too. If one quantity will decrease, the other will decrease too. Okay, what kind of variation is illustrated in this graph? So the x-axis is the hours work, and the y-axis, earnings through dollars or equivalent to dollars. So what have you noticed? As the R will increase, or the number of hours will increase, your earnings will also increase. So that's direct variation. Example, if y varies directly as x and y equals 24 when x equals 6, find the variation constant and the equation of variation. So this time, you're going to find the variation constant and then make an equation of the variation. Express the statement y varies directly as x as y is equal to k times x. Then solve for k by substituting the given values in the equation. Remember, the equation for the direct variation, or the formula for the direct variation, is y is equal to kx, or y is equal to k times x. So substitute the place of y with 24, and then substitute the place of x with 6. So we have our equation 24 equals 6k. And we need to solve for k, so we will divide 6 on both sides. So 24 divided by 6 and 6k divided by 6. So we have k is equal to 24 divided by 6 is 4. So our K, or the constant of variation, is 4. So therefore, again, the constant of variation is 4. And form the equation of the variation by substituting 4 in the statement y equals kx, because we have already our constant of variation value, that is 4. So we need to substitute that to the given formula to have the equation of the variation. So we have y equals 4x. That's our equation of the variation. Okay, the table below shows that the distance d varies directly as the time t. Find the constant of variation and the equation which describes the relation. So there are two quantities here. There are two things. There are two different things. We have distance and time. The variable for distance is d and the time is t. So we have our time is in hour, 1, 2, 3, 4, 5. And our distance is in kilometers. We have 10, 20, 30, 40, 50. So what have you noticed with the time? Is it increasing or decreasing? How about the distance? So this is a direct variation because the time increases, so with the distance. For our solution, since the distance d varies directly as the time t, then d is equal to k times t. Using one of the pairs of values, we get 2 and 20 from the table, then substitute the values of d and t. And d is equal to kt, and solve for k, or the constant of variation. So we have d, distance, is equal to k, that's the unknown, that's what we're going to solve, and the t is the time. So our d is 20, which means the distance is 20 kilometers, and our time is 2 hours times the k, which is the constant of variation, and that is what we're going to solve. So we need to divide to both sides, since 2 is together with the k. So 20 divided by 2 and 2k divided by 2. And that is k is equal to 20 divided by 2. K is 10. Therefore, the constant of variation is 10. And form the mathematical equation of the variation by substituting 10 in the statement. D is equal to kt. So we have our equation of the variation. D is equal to 10t because our constant of variation is 10. Okay, we will go to the real-life application of direct variation. A worker's paycheck P varies directly as the number of hours H work. For working 20 hours, the payment is 1,000 pesos. Find the payment for 45 hours of work. First solution, because H and P are in direct proportion, so we will use the formula for the direct variation. So we have P is equal to KH. P there is the money that we're going to pay, and the H is the number of hours or the time, where K is constant. So when H equals 20 and P is equal to 1,000, so if you work 20 hours, you will be paid 1,000. So to get the constant of variation, so we will substitute to the given formula. P is equal to KH. So our P is 1,000. Our K is a known. That is what we're going to solve. And our H is 20. So our K is 1,000 divided by 20. And that is 50. So our constant of variation is 50. Thus, our equation of the variation is P is equal to 50 times H, where P is the amount that the workers will receive, or the paycheck, and the H there is the number of hours worked. So when H is equal to 45, so if you will work 45 hours, how much will be your paycheck? So we have P is equal to 50 times 45, and that is 2,250. So if a worker will work 45 hours, he or she will receive 2,250 as the pay check. So those are the situations or the examples about direct variation. Okay, don't forget, like variation, we are the variables and God is the constant. People may change, but God won't. Should be dependent to God always. His love for us is constant because he never changed. Jesus Christ is the same yesterday and today and forever. Hebrews 13:8. Good day, everyone. I hope you learned something about direct variation.